Hey, good afternoon and welcome. My name's David Slik. I'm a technical director with NetApp in our advanced technology group and have a bunch of hats. My day job, I work on capacity storage, research and development, but I'm also a member of the Storage Networking Industry Association, co-chair of the Cloud Technical Working Group, and that's some of the work I'm going to be talking about today. So specifically, we're going to be talking about access control, pluggable access control in the cloud, and why this is something worth considering, different ways this can potentially be standardized, and some lessons learned with experimenting with this in the CDMI standard. So, what am I going to talk about today? I'm going to talk a little bit about access control. I'm sure everybody here is fairly familiar with access control and storage, so I'm not going to go through a full tutorial here. But there are a couple things I want to touch on in terms of why pluggable access control is important, is becoming increasingly important, especially as we see more and more cloud deployments. I'm going to talk a little bit about how access control fits into cloud storage systems, and specifically talk about it in CDMI. And then I'm going to talk a little bit about how we can do delegation, what this accomplishes, and show a demonstration of this working in a simple conformance CDMI implementation that we've used as part of our process for developing and making sure that the CDMI spec actually reflects reality. I'm a big believer that if there's not working code, it's broken. No code, spec's broken. So, okay, with that, if anyone has questions through the presentation, don't hesitate, just raise your hand. We can talk about it right then and there, and there'll be additional questions at the end. So, what is access control? Access control is a subset of authorization. It's what determines what the who can do to this, where what is the identity of the action. You know, can you read, can you write, can you execute, delete, etc. The standard storage operations, but this concept is more general. For example, if you look in the IoT space, are you allowed to move this actuator? Are you allowed to read the value of the sensor, etc.? This is a more generic concept, and as we see in cloud storage systems, these frameworks are being extended beyond just what we see in storage. So always keep in mind this. Well, I'm going to talk about this in the storage context. This isn't just storage. There's also the who. What is the identity of the subject, the actor that is initiating, that is requesting an operation to be performed? This we typically think of as us, people, but this is often not people. This is processes. These are software agents. These are other computer programs, complicated distributed systems, machine to machine. This is where a bulk of the transactions happen. And this is actually where a lot of the more complicated problems are. How do you determine who another part of the computer is and prove their identity? So once again, beyond the traditional models that we've tended to think about in storage, this has to be taken into account in these systems. And then finally, there's the this. What are you acting on? We're all used to files, but this is also programs. This is, in the IoT space, your sensors, your actuators, etc. You can have these complex relationships where, one processor is asking to write a value to another process. You have to, once again, make sure that that is allowed to do that, not just the action, but all the parameters. Now, this is distinct from, but often tightly coupled with authentication. Authentication is the means by which you determine the who. How do you prove that I am David Slik? How do you prove that this process is who it claims to be? Huge topic, huge amount of complexity there too. For now, we're going to set that aside. That's actually had a lot more work on it. We all have storage systems today that delegate for authentication. They'll go out, for example, to Active Directory. I pass my credentials in on my CIFS request, delegates to Active Directory. Active Directory resolves my credentials, determines my principal name. That then gets passed to the access control subsystem to say, okay, we've proven that David Slik is who he says he is. We're now going to act from this point on, assuming that that's valid, and we're going to go and ask the next question. Is David Slik allowed to actually do what he's asking to do? The storage system is typically what provides the what, the actions, delete, write, read, etc., and the this, the storage of the actual objects. So what we're going to look at how and where delegation of the access control decision as opposed to delegation of the authentication process, which is what's traditionally had most of the focus. So, just some terminology with respect to access control. A client issues a request. The request typically goes over a protocol of some sort. The protocol encapsulates the credentials. How do I prove I'm David Slik? And an operation, what I'm actually asking the storage subsystem to do. That then gets to a storage server, which then determines what my identity is from the credentials. That's that authorization delegation that typically happens. It then looks at the permissions related to the object and the action I'm requesting, delete this file, and determines, OK, that can be done, or nope, that's not allowed. The resolution of the credentials, as I mentioned, is often delegated. And permissions have often been tightly coupled with the objects and the operations themselves. So there's a number of different kind of classical models for access control. Not going to spend too much time on these because we're mostly familiar with this. There's discretionary access control. The most widely known form of this is, for example, you have secret, top secret, et cetera, classification level. There's an administrative policy that says if my classification level is secret, I can't read top secret, et cetera. And those aren't defined on what I set. Those are defined on what the administrator sets. There's what we're all mostly familiar with, which is the mandatory access control. This is where I own a set of objects, and I can define the controls for those objects. So I can say, I own this, and you're allowed to read this, and you're allowed to write this, et cetera. We're all familiar with this in the form of access control lists, ACLs. And then there's role-based access control. This is kind of considered the state of the industry. There's improvements beyond this, but this is considered best practices. And it's in essence adding a layer of indirection. You've got your identity, you've got your organizational roles. I may be an administrator of this data, I may be a user of this data, et cetera. And you resolve from identity to role to access. Because I'm an administrator, I can delete this data. Because I'm part of this other role, I can read this data, but I can't, for example, delete it. And we've probably all seen this. ACL groups are often abused for this specific purpose to not really have to extend the traditional ACL model. So why is this not good enough? Why do we want to look at delegating? Why do we want to look at changing? Well, what's happening is there's a lot of emerging methodologies around access control. And there's been a lot of research over the last 20 years looking at some of these edges. But it's only really in the last 5 years that we've really seen a lot of demand coming for these alternate ways beyond ACLs, and especially in the cloud. So let's look at some of these emerging areas, just so we can get kind of a feel for why customers might feel restricted with ACLs, and why customer applications deployed in the cloud might want to see something extended beyond that. Well, the one that's the furthest along is what's called attribute-based access control. And there's actually a standard around this, ACML. And it's OASIS standard. It's quite well developed. There's products out there. In essence, what it says is when I get a request as a storage server, I can delegate out to an external system, and I can provide it with information about what's being accessed, by who, et cetera, all the details we provided earlier. And then that system can go and look at other properties. Oh, OK, David belongs to this group, or this data being requested, et cetera. It's pluggable, it's flexible. It allows you to look at additional attributes beyond just what a storage system happens. So that's good. That shows there's demand. This has been fairly widely adopted. I'm not aware of any integration of this into major cloud frameworks, but it's a standard, a great first step. One of the areas that we've started to see a lot of deployments is graph-based access control. You're probably familiar with this with a friend of a friend. If you friend somebody, they can then see your friend's posts, or depending on how the security policy is. You're looking at these graph relationships, and you're defining access control based on those graph relationships. I belong to a group, someone else belongs to a group, that person then has some degree of read access to resources I may create, etc. And as we see more and more use of graph relationships as driven by social media, but we're starting this across all areas, all segments of the industry, defining access control based on declarative statements on these semantic graphs of relationships is something people want to do. Right now, they're typically having to write their own frameworks, access control layers that sit in front of the storage system. And anytime you have proxies like that, anytime you have an access control layer that sits in front of the storage system, that's a potential security vulnerability. Because if anyone can bypass that front proxy that performs the access control, they just bypassed all your access control, and often they can get access to all the data. So ideally, you want to have that access control enforced as part of the storage system. So what about another example? Biometric access control. This is where you take information about it's kind of a blurring of identity, authorization, and access control. But for example, taking, you have your phone, you get the fingerprint, there's a unique little identifier generated from that. That gets passed all the way through. You want an external subsystem that can go and look, okay, this matches, I'm going to allow access. Or the data's encrypted with some of that information. That's another area where there's a desire to move beyond ACLs. Location-based access control. You see this a lot in content management, etc., where you may want to do geofencing. The credentials may include information about my geographic location. And I want to be able to pass that into the storage subsystem. And the storage subsystem may deny the access because I'm outside of the geographic region where I'm authorized to access it. There's more. Context-based access control is methodologies that have been developed to allow operations to be allowed or disallowed based on the context of surrounding operations. A great example of this is where a request to update the contents of a file may be denied because it's a whole file replacement with high entropy data, i.e. the ransomware that co-opted my credentials is trying to replace my files with encrypted versions so it can go and try to demand some bitcoins. Similarly, capability-based access control is taking concepts of capabilities, which is where I have a special token that allows me to do an operation. And I can present that token, that capability, which then allows me to do it, kind of the bearer token model. You see this in, for example, some of the S3 signed URLs. If I have the URL, I can access the file. That model doesn't quite fit into traditional ACLs very well. But lots of people want to do it. They want to have a simple thing that if you have this magic string, you can do the operation. And then finally, we're starting to see a lot of research and a lot of people looking at risk-based access control. This is where you start to dump all sorts of data about operations, about behaviors, about profiles, about what's going on in your system into some of these emerging techniques. For example, deep learning, AI-based, to start to build risk profiles. And the risk profile may say, great, I don't mind that. That operation looks good. Oh, I'm not sure about this. I'm going to deny it, or I'm just going to flag it or alarm it, etc. These are all areas where people are wanting to innovate. People are wanting to extend. And right now, they have to put these proxies in front of the storage system. They can't replace, they can't augment the traditional ACL-based access control. So that's what customers have been coming. That's what we've been seeing in the industry. That's why we believe this is an interesting area. So what does it look like in cloud storage systems today? Today's cloud storage systems are built largely around the traditional storage model. You have your operations, your create, read, update, delete, maybe server-side copy, etc. These are performed on objects, whether they're files or objects or key value stores. S3 is a key value store, for example, in my books. And the identity is determined by verifying credentials And since we're talking about cloud, this is almost always done over HTTP transactions, and the credentials are usually carried as a series, one or more HTTP headers. You may have exchanges back and forth, if you're using OAuth, et cetera. It's a little more complicated than that, but ultimately that's the basic model. And looking around at the big cloud storage systems, none of them are supporting this form of delegation. They're all supporting delegation of authentication, i.e. who am I? But they're not supporting this level of delegation. So there's not only a need, there's a gap. So why is this a problem? Well, if I'm a customer and the cloud storage system isn't suitably or sufficiently expressive or extensible, it may be unsuitable for me. I either have to choose to do a whole bunch of additional development, i.e. put proxies in front, which may architecturally result in security trade-offs that may not be acceptable to me. Now, we've seen the DoD grappling with this. They want to go into the cloud. They want to have the benefits of the cloud. They don't want to have to develop their own cloud. But at the same time, they have mandatory requirements for access control way beyond what the traditional kind of fast and loose S3 bucket type access control provides. Similarly, what if you're building your whole application and you don't want to be linked to one cloud? You want to be able to run your application across multiple clouds. You want to be able to choose which cloud you're going to run based on, say, economic or load or geographic purposes. Different cloud frameworks have different access control models with different semantics. And this is complicated if you want to be audited and you want to have regulatory certifications that say this data is secure. If you have to deal with all the permutations of the interactions between your code and the cloud storage subsystem and the security models, and you have to have that certified across multiple cloud platforms with multiple adapters in multiple regions, that's a much more complicated certification exercise than it is if you have some way to say, well, all the access control decisions are performed by my code. You can then certify that and say that regardless of which cloud platform, they're delegating to my access control framework. And therefore, it's a lot less work. I have a lot more certainty that it's doing the right thing. I can spend my time making sure that that code is secure and performing correctly, rather than having to deal with this n times m times O type permutations of complexity. So cross-cloud portability is another big reason for pluggable access control. The other issue is these cloud systems are constantly changing. And this is a really big transition that a lot of the customers we work with in enterprise systems, it takes them a while to really understand this. And then once they do, it makes them really worried. Well, what do you mean? It may work differently tomorrow than today, and I won't even know about it. And it may not even be one consistent change. It may start working differently in this region first and then change in this region later, et cetera. That's a lot of worry that enterprise providers dealing with security critical systems have, because does a bug in a feature push mean all of a sudden things they thought people didn't have access to did? A great example is Facebook changes their security policies, and all this content, all these posts you thought were private are now public to some subset of your friends or other groups you belong to. You don't have this certainty because you're relying on another provider that has their own release schedule and are pushing builds all the time. If you want to have control over that in a consistent way that only changes when you allow it to change, you may want to bring that back in-house. You may want to control the access control process. And then finally, there's people who are just like, I love the cloud, but no, the cloud isn't going to be making the critical security decisions about who can access what. I want to keep that in-house. And it was that fourth one that we originally started looking at in SNIA, and I'll talk a little bit about that in a minute. The first three aren't really well addressed by where we went to in this initial work. So what I'm presenting here is about addressing more of those first three, because with the last one, you really need the objects encrypted as well. And that's, if you're interested in that model, I gave a talk on this the previous year, 2 years back, and I'll have a link to that presentation later in this one. Okay, so just a little bit of a history. One of the interesting things that NetApp did is back in 2002, we actually implemented access control delegation in our filer product. For those familiar with NetApp's filers, we have a feature called F-policy. And in essence, what F-policy is it allows you to say for a given set of volumes and files on your volumes, when a user performs an operation against it, the filer will go out to an external system and say, is this user allowed to do this operation? Are they allowed to delete this file? Are they allowed to create a file here? Etc. And it sends information about the operation and about the user and about the file, etc. And this has been really successful for our company. We have a lot of third-party integrations ranging from file screening, reporting, quotas, archiving, replication, and most importantly, data governance. So I bring this up not to promote NetApp, but rather to say, here is a demonstrated customer need from the enterprise market that isn't being met in the cloud. So not only are we seeing this theoretical, not only are we hearing people talking about this, we have a successful model for the functionality that there's currently a gap. So let's look at this from a more concrete standpoint. How does access control in CDMI work today? So in CDMI, you have your CDMI client. And this is a standard HTTP client that wants, let's say, to read some data. It'll send a GET. It'll include with that GET the credentials. It'll include information about which object it wants to read. So those three pieces of information we talked about earlier. That gets sent to a CDMI server. CDMI servers, like most cloud storage systems, like most storage systems these days, delegates the credential lookup. The identity. It'll send the credentials, in this case to Active Directory. Active Directory looks at those credentials, says, OK, yep, this is indeed David, MFA or tokens or however it's configured to set up to resolve that, and comes back and says, here's the principal. My credentials may say David Slik, my principal may be D Slik. So it does that mapping as well. So the CDMI server receives the result from Active Directory and says, OK, yep, Active Directory says it's good. Here's the principal. And then it performs ACL evaluation. CDMI uses NFS v4 style ACLs, which is a superset of what you see in CIFS, in older versions of NFS, in most file systems. And it behaves pretty much as you expect it to be. It will walk the access control entries in the access control list, map against the principal, and if it's an allow, depending on the ordering of the allows and denies, that gets really complicated. People mixing allows and denies in a single ACL, it's bad, but people still sometimes do it. You go through the list, it says it's OK, then the response comes back with the data, everything's good. So that's how it is today. But what do we want it to look like? What we want it to look like is a means to delegate this. So we started looking at this in 2015, 2016, specifically around electronic health records. We had a number of groups that were working on electronic health records, that were using CDMI, that wanted a means to be able to handle this expressibility. Because ACLs don't work for electronic health record. If someone's dying in the operating room, the last thing they want to be able to go is say, sorry, our patient died because the ACL said no, and we couldn't access the file, and we didn't see the information we needed, and the surgeon wasn't able to do what they need, and they're dead. So in healthcare, there's very, very different models. And they've, in many ways, been pushing the boundaries of access control and security and confidentiality because they've got these wildly contradicting requirements. In healthcare, you want everybody to get access to everything they need because otherwise really bad things happen. But in healthcare, if the wrong people get access to it, it's bad. So there's a lot of mechanisms in healthcare that break the existing model. For example, there's a way to kind of break the glass, bypass all the access controls. The person can read everything, but that triggers all sorts of audit and investigations and was this done properly, kind of the emergency access model as a simple mechanism. So if you're having an electronic health record system and you need to have a way to bypass the ACLs on a selective basis, that may be based on the fact that I'm an ER doctor. And because my role as an ER doctor, I can override the ACLs when I'm in the ER, but not when I'm outside the ER, not when I'm at home. And this, we needed a way to integrate this. And the other thing, because of electronic health records, you want everything to be encrypted. So we put together an extension to CDMI called the Delegated Access Control extension. And this is up on the CDMI website. You can view the entire document by just Googling for CDMI DAC extension, and you can read the whole thing. It's really good work. It's great. It has integration with encryption. It has delegation. It has asynchronous access. It complements ACLs, etc. Perfect. But it's also fairly complex because it's trying to solve a fairly complex problem. So we looked at this and said, OK, well, we need a simpler model by which we can delegate these access control decisions beyond tying into encryption and assuming a certain access model, etc. And that's what we're talking about today. A means that allows you to replace the ACL-based system altogether. So this is what the DAC, that encrypted system works, where you would have encrypted objects stored, and then the keys for the encrypted object are stored in a key management system. And when you go to access that content, there's special metadata about the encrypted object, and then you can put together a request which can get forwarded asynchronously through multiple layers of systems, and then finally it gets to a originating server that talks to the key server after it makes an access control decision to then provide the keys and package them up and deliver them all the way back, and then the data can get decrypted and you can receive it. As you can see, pretty complex. It's mixing a bunch of different things together. Just delegating access control doesn't have to be that complex. You request the access. There's some means to indicate ACL delegation, access control delegation. There's some sort of a provider that makes access control decisions. It comes back and says yes or no. And if yes, the operation succeeds. So much simpler integration. And that's what I'm going to demonstrate in a few minutes. So how does this look? Well, in our earlier model, you do the get credentials in the object. That goes to the server. It looks it up from Active Directory, gets back the principal. But instead of resolving the ACLs in the CDMI server itself, it delegates out to a provider that assumes that functionality. It sends the principal, the who, dslick, the operation, get, the identifier, myfile.txt. It can do whatever it wants. It can look at the graph. It can look at my history. It can look at where I'm geographically located, phase of the moon. Doesn't matter. This can be implemented by someone else, not by the storage system. Let's say it says, OK, full moon, you're allowed to access it. CDMI server says, OK, I'm good, and I get the object. Any other time, nope, you're not allowed to. So there's two different ways you can do this in CDMI. In CDMI, when we talk about authentication, right, delegating out to Active Directory, we use the concept of a domain. In CDMI, every object belongs to one domain, and that determines who you delegate to for your identity. The example we use, the use case, is take the ACM and IEEE. They share a common repository for all of their papers. So you have a single namespace, and you'll have a paper, dslick 1997, dslick 2003, one published in ACM, one published in IEEE. Common namespace, but two different administrative owners. When I authenticate into ACM, I go through one authentication provider. When I authenticate in with IEEE, I go through a second authentication provider. So those two objects, one would be in the ACM domain, and one would be in the IEEE domain. So in CDMI, the domain determines where you delegate. So you can do the same thing with access control. You can say if it's the ACM domain, I go to the ACM access controller. If it's IEEE, I go to the IEEE access controller. This is a relatively simple extension to CDMI, but it kind of has some issues. And the big issues are that authentication and access control aren't always fully aligned. And they're often at different granularities. I may need to have different access control for different files, let alone for different domains. So if we forced it into the domain system, while the domain means is still valuable, we wouldn't want to have to create a new domain each time you want a new way of delegating access control. So we looked at a second method. If you, before we go on to that, if you look at it in option 1, which is the domain-based, instead of the way we specify delegation of authentication is we specify that it's a delegation for members, and then we provide a URL to LDAP or Active Directory, et cetera. So you would do something relatively simple for access control. You'd have a CDMI access control enabled, access control type delegation, and then a delegation URL telling it where to go. OK. So the other way to do it, and the way that is more intriguing and more generic and more extensible, is to say, what if we created a new ACE type? So in an access control list, there's a series of access control entries. And the access control entry might be like deny everyone, et cetera, or allow dslick, principal, et cetera. If we created a new ACE type and used for the identifier the URI to the provider, this is a number of really interesting properties. The first thing is it's sticky to the object. So as this moves around from system to system to system, the delegation is preserved. And in any system that preserves ACLs. And even with archiving, even if the domain changes. So this makes it very, very flexible. This also means you can have fallback permissions. So if this isn't available, your system can be configured to either halt or continue processing with a more restricted set, et cetera. So you can deal with the scenarios where your access control, your delegation system isn't running or isn't accessible for whatever reason. So it's a bit more flexible there as well. So that's where we went and looked at, OK, well, this is interesting enough. Let's do a quick prototype and see what this looks like. So we did a proof of concept. The way that we work in CDMI is there's a base specification. Vendors build on that, and they will write extensions to that. And if a vendor is interested in contributing that back to CDMI, they come to the standards body. CDMI is open. Anyone who's a member of SNIA can join and attend the meetings. Oh, and as of today, the CDMI specification itself is now publicly available on GitHub. You can just search for CDMI spec on GitHub, and open to anyone who signs a contributor agreement to be able to push suggestions, improvements, extensions to the standard. So not only is CDMI an open standard in terms of that, the traditional form of open, it's fully open in terms of that the standardization process itself is fully open. So a vendor wants to add some functionality. Like let's say we want to add this access control functionality. We would write it up, document what we were proposing to do. We would then show that we have working code, because once again, we're very big on if it doesn't have working code, it's not actually, it's broken. And the standards body, the CDMI technical working group, would talk it over, and if everybody there were no major objections, it would get published in the next version of the spec as an extension. Once 2 vendors demonstrated working code and interoperability, then it gets moved from an extension into the actual body of the spec. It's no longer called out as something proposed and upcoming. It's just part of the CDMI specification. So we went and we looked at this and said, well, let's do a first implementation. Let's see what this would work. Does this meet the user requirements? Does this meet the goals outlined earlier? And that's the code I'm about to show you. We did notice that in the initial implementation, there were a couple gaps. This isn't something that would be fully ready to go into the spec. For example, what is the best means to handle load balancing across multiple access control providers? For a domain-based model, would it make sense to use CDMI scopes? CDMI scopes are a way of saying just this subset of the content have this access control delegation apply to, et cetera. So there were, this isn't something that's fully ready to go into the spec, but it's pretty close. So with that, I'm going to give a live demonstration. What I'm going to demonstrate is I'm going to demonstrate a CDMI server. This CDMI server is written in Ruby. We've used it to verify that what's in the spec is indeed implementable and makes sense and operational. We're going to demonstrate a pure HTML5 client. So one of the neat things about CDMI is your client can be completely web-based. We're also going to show the Open Policy Agent. Open Policy Agent is an open source policy engine that you can use, for example, for access control decisions. So we're going to go and take have some objects in our CDMI server, and we're going to have the access control enforced by a policy loaded into OPA. Okay. So let me get this set up. So I have 3 windows here. Hopefully this is visible in the back. I apologize, the text is a little small. And I'm going to run 3 things. So on the bottom here, I have my CDMI server. So I start that up. I have a CDMI server running in secure and insecure modes, et cetera. In this window here, I'm going to start up a really simple little access control provider. And this makes decisions about the policy it enforces is if it's me, it lets me do it. So, and then we're going to have a more complex one loaded into OPA. So I'm going to start the OPA server here. So as I go through, I'll talk a little bit about the policies and how these interact. So now I've got the 3 servers running. So I'm going to go over and I'm going to go to my, my web-based client. So the first thing it's going to want is my credentials. Prove who am I and prove that you are who you say you are. So I'm going to go through and I'm going to log in. And here we see the contents of this CDMI server. I have a couple objects here. I have an object here called index.html, which is actually this client self-hosted. So what you're seeing here, this is all JavaScript coming from index.html. I have a folder called finance. This is where the OPA policies are going to come in. I should only be able to see my confidential information. I shouldn't be able to see someone else's confidential information. We have a little test file here, and we have some images. So this is all hosted off the CDMI server. If I click on images, for example, I can see a pretty picture coming off the server. Pretty straightforward. Okay, so what does this look like? So if I go and I take a look at here, I see that I can look at the CDMI representation of the object. Now, we're interested in the ACL. So right now, I have an ACL that says delegate to this program running on my local server. So whenever I go to access this object, it's going to go out and delegate. So if I go and look at what the program was doing, I can see here that there were a bunch of delegate requests coming in. So every time, so if I go back and I close this and I open it again, there was a new one. So each time I go to access that file, the CDMI server here was delegating out to the program as specified in the identifier field of the ACE, connecting to that provider, sending information, user dslick, path test.txt, method get, All that information was there. This program went, looked at it, said, yep, it's dslick. I'm happy with that. I'm going to send back an allow. And we see here the allow was provided. So what about if I'm not dslick? So if I go and I log out, and let's go in as jdo, and I go and log in here, and then I run the query, and ooh, the file isn't even visible. So I go back in here, and I look, OK, now it sent a delegation for user jdo, and it denied. And as a result of that, I can't access the file anymore. So there's our delegation. So let's look at a more complicated example of this. So I'm going to go into finance, and I'm going to go into salary. Now, there's jdo. So what happened here? What happened is, well, let me show you. In jdo, there was also an ACE of delegate, but it's pointing to a different program. 8181 is where OPA is running. We're running against the auth's policy in OPA. So if I go and I show you, that's the CDMI spec. Let me just get that OPA up. OK. So under OPA, the policy here is looking at finance salary. So this is specifically for the salary documents. And it's looking at username. And it's looking at whether I'm in the username list or whether it's as a managerial relationship, someone I'm managing. So this is an example of a relatively non-trivial policy implemented in a policy language being run by OPA. So if I go and look here, you can see that the requests went here. There were a number of different requests. It doesn't show, but in essence, it's checking whether I am allowed to access as jdo. Can jdo access dslick salary? In this case, it denies that. So if I go and I log out here and log back in as dslick, and I go and look, OK, oh, now dslick shows up. So this is showing a non-trivial delegation policy enforcement on an object-by-object granular basis through to a CDMI-based system. So I can go back and I can go and show you just how I can change this. Like, for example, this object here, I can go in and I can go and I can edit the ACE. So I'm going to change the owner to dslick and users. And I'm going to change this to delegate. And I'm going to put 127.0.0.1:5000. That's my server. Oh, one more 0. And I'm going to save my changes here. And I still can access it. But now the delegation was going through to here. You notice that its images, that particular image is now going and doing the delegation. So changed in real time by changing the ACE. And if I log out and log back in as jdo and demo, log in. Remember the first one, 822A? It's gone, because the policy engine said, nope. So that concludes the demo. And if I go back here to full screen, it demonstrates that this is a simple approach, the concept of adding a new ACE type. It can be standardized into any system that uses ACLs. So for example, this isn't just something that can be applied to CDMI. This same approach would equally apply to, for example, S3 ACLs, Google Cloud Storage, any system that uses NFS v4, CIFS, etc. And this provides a portable means for access control delegation. So with that, that concludes the bulk of my presentation. We're going to continue talking about this in the SNIA Cloud Standard, Cloud Storage Technical Working Group. This will probably make it out to an extension. And if you have any questions, you can ask now, or here's my email. Question?
So when you were trying to show the access control policy, it looked like it also was doing access-based enumeration. Is that part of the spec?
Okay, so the question was when, let me get this up, when we were delegating out to the policy engine, was it not only doing access control, but also enumeration?
Yeah, access-based enumeration.
So I'm not exactly sure how you would define access-based enumeration. So
You probably won't see why you don't have permissions.
yes, that's correct. And that's because when CDMI does listings, you can, that's based on visibility, which is based on the ACLs. And if you've got an ACL delegation, then when it goes through to determine the enumeration, the listing, that's going to reflect those privileges. So anytime an object with a delegation exists, that information is going to be reflected. And that's why every time you saw when I, for example, changed the ACL, it disappeared because it was no longer visible because it no longer had the permissions to do so. So the answer is yes. Yes, that's correct. And that's another function. And a lot of people use access control delegation, even if they're just saying, go ahead and use the existing ACLs to add hooks for auditing, for logging, etc. And the ACL standard actually has a mechanism in there. There's two ACE types in the NFS v4 standard for audit and alarm. Very few people implement that. Most people will just want a hook. But one of the differences is for auditing, typically people will want to get called every time everything happens. They don't want it on a file granularity. They want it on like a bucket granularity or a volume granularity. So this is, remember where I talked about there were kind of two different approaches to this? You could do it at the domain level, or you could do it at the object level. The auditing use cases work better at the domain level, which is why we most likely, if we take this to an extension, would propose both. Question in the back.
I might just have missed that, but I understand that the delegation you show is asking about the ACL. So how about setting the ACL? So is that going through the main system, or is that going through the system which is actually then asked for the ACL?
So the question is, in what was demonstrated, it showed the delegation providing an access control decision, but where is the ACL set? Is that correct? Okay, so there's two different answers to that. The first answer is, once you delegate, how the delegated system manages is up to it. The second part of the question, and if I go back to my demo here, is how are these ACLs in CDMI set? And there's a standard interface for updating ACLs in CDMI. So for example, if I go and I change this, I'm going to delete this ACL. It's this ACE, right? I just go save changes. That's doing a CDMI operation back to the CDMI server that went and updated the ACLs. So and once again, CDMI, because it's standard NFS v4 ACLs, you have inheritance and all of those sorts of things. So I could go and change this from an allow to a delegate using existing CDMI interfaces to make those updates. Does that answer the question?
Yeah, so just ask. So that means that the main system, which you're going to protect by the remote ACLs, can set the remote ACLs.
Yes, but there's an ACL that determines if you can set ACLs. So once I have changed this to delegate, I can't go and change it back unless the external system lets me.
Yeah. So then, last question.
Yeah.
So, is that part of the specification how the master system, with all the object, is trusting the remote
Yes, absolutely.
Okay.
Question?
So you said you are using NFS4 ACLs, isn't it?
Yes.
So if we have any alarm ACLs, will that honor that?
So once again, standard behaviors. So if you want it to fall back, you would have different behaviors if you have an allow, deny, deny, allow, presence of an allow, presence of deny. We don't propose on changing any of that. The only thing that having more ACEs than just the delegate lets you do is express these things. Some of them may not make sense in some security contexts. Some of them may be great. One of the things we do have to define is what happens if there's a delegation ACL and the delegation ACL is not reachable. So that would be a really critical security specification. And with that, we are out of time. So thank you.